Hi guys, this is Miss Robinson, and in this video I'm going to show you guys how to use your STAAR reference materials to figure out if something is soluble in water or not. Remember that the term solubility basically tells you whether or not it can dissolve in water. So here we're dealing with ionic substances. And if you guys remember, an ionic compound is when we have a transfer of electrons. So when one atom transfers an electron to another, leaving one with a positive charge, which is usually a metal, and one with a negative charge, which is usually your non-metal or polyatomic ion. Okay, so with that said, let's look at this chart. If you see by this chart, all of these ions are anions. They're negative. They are a mix between normal anions that you see on a periodic table, like these here and this one, or they're polyatomic ions, which you see over on this chart, with the exception of one cation, which is ammonium, excuse me. Okay, so to read this chart, the way that this works, if you see here, all of these up here are soluble in water. So any compound that contains these anions are going to be soluble, unless it meets one of these exceptions. That was a horrible line. Anyways, so if you notice, all of these above this line have no exceptions, which means that they are always soluble, regardless. Below this line are soluble unless they're in a compound with any of these listed. All right, so for instance, AgBr, silver bromide, would not be soluble because it's an exception. Usually bromine is soluble, as it states here, but since it's in a compound with silver, it makes it insoluble. If we had a compound with bromine with potassium, so potassium bromide, then it would be soluble, since potassium is not any of these. So this one is soluble, this would not be soluble, which basically means this potassium bromide would dissolve in water, silver bromide would not. Okay, the bottom of this table, it tells you compounds that are insoluble. Insoluble meaning they do not dissolve. So any compound with any of these, what is that? Any compound with any of these anions are insoluble unless they are in compounds with one of these. For instance, first of all, notice that they say alkali metal cations. Right, alkali metal cations, if you remember, the alkali metals are the first column. First column. Or group. First group. We'll do superchemistry terms. First group on the periodic table. Okay, so anything with, for instance, if you have carbonate here. Carbonate is usually insoluble unless, which means it cannot dissolve, unless it's in a compound with ammonium or any element from the first group on the periodic table, the alkali metals. For instance, sodium carbonate. This would be soluble because sodium is an alkali metal versus iron carbonate, which would not be soluble. Not soluble. Okay, now that you guys know how to read this table, let's move down and let's work a few problems. Okay. So this worksheet for this first part, basically all you're doing is labeling whether it's soluble or insoluble. So this first one, oh look, it's the example that I have, potassium bromide. Okay, let's go up here and look for bromine. Okay, bromine here, it says that it is soluble, and potassium isn't one of these, as you guys remember here, potassium bromide is soluble. So you guys would simply write, I'm going to be simple and write an S for soluble and an I for insoluble. Okay, let's look at this one. Lead carbonate. Lead carbonate. All right, I'm up here. Here's carbonate. It is insoluble, and lead is not one of these, so that would mean that it remains insoluble. Okay, let's go over here. One more, barium sulfate. Let's find sulfate, because you're always looking for the anion. Here's sulfate. And barium is one of these. Okay, so sulfate is normally soluble, but since it is in a compound with barium, then it's the opposite. It's an exception, so this would be insoluble. Okay, I think you guys get that gist on how to do that. Keep in mind, though, that you're going to have to know your naming rules for a lot of these. Okay, you got to know how to name. Okay, now this next one is a chart. Basically what you're doing in each one of these boxes, you are writing what the products from this or this, from like, right? So this first one would be with potassium bromide and silver nitrate. This one would be if potassium bromide and barium chloride were reacting, and so on and so forth. Okay, so for each one, you guys are writing the products. If you are writing the products, remember that we are dealing with double replacement reaction, or up there it says double displacement, same thing. Basically what happens is your two metals up here are going to switch places. Okay, so here we have silver, we have potassium. Okay, potassium's got a plus charge since it's on the first row on the periodic table, bromine a negative charge. And over here, silver is a transition metal, so we don't know its charge, but we know that nitrate has a -1 charge, so that means silver must have a +1 charge. Okay, now let's see what the products would be. If silver and potassium switch, that means silver is going to be with bromine, so it'd be AgBr, silver bromide. And that means potassium is going to form with nitrate, so it'd be KNO3. And make sure that you are writing them correctly. Make sure all your charges balance out, and they do. Now what you do is you circle the ones that are going to precipitate. Basically that means that whichever one is not soluble in water is not going to dissolve. It's going to precipitate out of the solution. Okay, so let's look at silver bromide. I think I used that one. Oh, look, here's silver bromide. Remember, we have bromine, which is normally soluble, but since it's with silver, that's insoluble. So we're going to circle that one. All right, we can check potassium nitrate. Up here we have nitrate, which says that it is soluble, and there's no exception. So anything that bonds with nitrate is good. So that one you just don't circle. Okay. Let's do one more. We'll do these. So we have barium that has a +2. Chlorine's obviously a -1. Let's switch those. Barium with bromine would be Ba, Br2, with potassium chloride, so KCl, because that's +1 -1. Okay, let's see if any of them are going to precipitate out. Potassium chloride, so let's look for chloride. Here's chloride. Potassium is not one of these, so that means that it remains soluble, so that one's good. That one's not going to precipitate. Barium bromide. Here's bromide, and barium is not one of these, so both of those are going to stay in solution. They're not going to precipitate out, so you don't have to circle any of them. Okay, guys, I hope this helped. And good luck. I hope this helped with learning solubility rules. Bye.